Okay, so next is activity 262, using matrix transformations to describe geometric operations. So here we have on the left, we have a plane, and we have a little box showing kind of what is going to do to the area. And then we've got an arrow to try to show the orientation of the box. And then over here, we've got the same box, the same arrow, because from here to there, we're applying the matrix A, B, C, D. And right now we have 1, 0, 0, 1, which is the identity matrix. Now, so that's already answers part G. So part G, take it off the list. Now, we're going to answer part A. What happens if we have the matrix 2, 0, 0, 1? So change this to a 2, and look how I'm stretching everything a factor of 2 in the x direction, but the y direction is staying the same. And so in that case, that matrix stretches everything in the x direction. Now for part B, the 2, 0, 0, 2, then if you did this, now I'm stretching in the x and y directions the same amount, so I'm just multiplying basically all components by 2. So in that case, the area becomes 2 by 2. It's like a 1 by 1 square becomes a 2 by 2 square, meaning like the area gets multiplied by 4. And then notice how the orientation arrow is still on the bottom, so we're still oriented the same way. Okay, now what about 0, 1, negative 1, 0? So 0, 1, negative 1, 0. So now we have, notice how the box has moved from here to there. And since the arrows also moved from there to there, we can see that it rotated in that movement. And the box is still the same area. It's just rotated 90 degrees clockwise. So this is a 90 degree clockwise rotation. All right, now let's do 1, 1, 0, 1. So 1, 1, 0, and 1. And now this is called a shear. It's a shear because our square has turned into a parallelogram. And the parallelogram still has height 1. It still has height 1. It still has base 1. That means the area is still remaining the same. We're just imagine if our square was made up of a bunch of like stacked Jenga blocks. We're like moving them all over a little bit on top of each other, and that's a shear of the plane. Okay, so D is a shear. E is negative 1, 0, 0, 1. So let's do that one. Negative 1, 0, 0, 1. So now negative 1, 0, 0, 1 is multiplying all of our x values by negative 1, and our y values are staying the same. And so now we see that the arrow is flipped on my box, because in this box, the arrow is going counterclockwise, but now my arrow is going clockwise. So it's been flipped across the y-axis. Okay. So then what happens if I have 1, 0, 0, 0? So 1, 0, 0, 0. In that case, we are flattening the entire plane onto the x-axis. And so there is no volume, there's no area left. Everything's become flattened into one single line. So it's the fancy word for it is projection. It's a projection on the x-axis. Okay, and then G, we started with that one. So then for part H, 1, negative 1, negative 2. 1, negative 1, negative 2, 2. Okay, sure I get these perfect. There we go. So now our box has been flattened onto this line, but also stretched. So it's sort of flattened and stretched on this line. Where you see the blue there becomes the blue there. This line becomes that line right there. Okay, and that finishes that Act